Hello friends, this is lecture number 2 on Staad for software. In lecture 1, we talk about the features and hierarchy to design and analysis a structure. Now in this lecture, we will see how this software works. Firstly, we open Staad Pro software by double clicking its icon on the screen. The Staad Pro start page will be displayed automatically when the program is opened. From here, we can open our new project from the taskbar or open our previous project from the save folder, and we will also configure our file default configuration. That is, we can set our base unit, metric or English. We can change our background color, that is black or white, and we also can change the state default design codes. That is, we are using our Indian standard 800 for steel designing and IS 456 for concrete designing and IS 13920 for shear wall and its design. And then click apply to apply it on our new files. We can also change the global axis orientation, that is y axis upward or z axis upward, etc. From recent files, we can see preview of our projects that we had worked on. We can see its image in a right hand side window. From here we can choose our default codes used for design, as this software contains more than 20 countries codes. Now backup manager bar is similar to other software. This software can also allow us to do periodic backup of our working file, whose time can be set from here. Right now it is 5 minutes. After 5 minutes it will auto save our file project. Now let us proceed to the example. Click on a new project. A new dialog box open asking for units and working plane and name of the project and its saving location. As we click on working plane definition, definition of the plane appears in dialog box, which helps to select working plane. Let name our project as practice 1. And before selecting the saving location, always remember to save it in a blank folder, because this one file replicates its static data in various small files which are also saved in destination folder. That right now I am saving it in my Staad Pro file. Now by clicking on next button, a new dialog box open which asks us where we want to go first. And for every place, its definitions is shown in dialog box. Same for solid. You can see a preview of that in right hand side screen. Same for state editor. Now select anyone and click next. That is finish button. Now main Staad user interface open. Now before starting our exercise, just recall our lecture 1. At the top one is the menu bar having drop down panels, the edit bar having different drop down toolbar. Similarly, select for beam cursor for physical member and different tools are there. Similarly for geometry. Then we have toolbar box from where we can edit our structure using different tools. Let's zoom in, zoom out, or we can change the view of our viewport, front view, back view, top view, isometric view. Then on the left side is the page bar, which have many tabs. In different tabs there are different subtabs which we are used to model and design our structure. Then the main screen at the middle, and on the right side the data area displays the dialog, tables, list, and so forth, etc. and etc. And at the bottom, coordinate status bar presents helpful information regarding the status of the program, and the bottom left corner showing the coordinate system with y-axis upward as we defined it in start page. Now for selecting beam node, we have to select different cursor. It is not tired selecting those members as node cursor. You can select different node cursor. Difference in beam cursor. Now we had selected beam cursor. Then now we are selecting plate cursor. So we can differentiate different cursor for different elements of our structure. When we need to find nodes, we will use node cursor. Now as per hierarchy, we first provide job information, which will shown in our final output file, that is client name, job title, reference id, etc. etc. Let us give job name 1, client name, student, and reference number, EFO builders. Now we come to our general geometry tab, helps to model our structure. Now the main screen showing the snap node grid in XY plane of 10 cross 10 meter grid, which can be edited from the data area by simply click the edit button. A pop-up blocks autosave option appears. Now click OK to close this dialog box. Let us see the save file location in our computer. As you can see, all these files are generated from our project, and it will be increased with increase in data of the project. Okay, now with the snap node beam mode, let us model a simple two-way frame structure. Use escape button to finish the mode, and for restart press the snap node beam button at the bottom left of dialog box. Now close the snap node beam dialog box from data area, and now we can easily see the input data in nodes and member form. As we click on node, the node will appear in red color. Similarly for the beam members. Now to see the member reference number and no number, use shift plus N for finding nodes and shift plus B to find beam number. The red number shows beam number and the green number shows node number. Now to know information about any element, just do double click on dialog. A dialog box open showing its property, that is node 3 XYZ coordinates. Moving a step ahead, now we assigning material properties to element member. From data area we can assign different section from property tab by clicking define property. Here we are having different sections which we can use in our structure. This is general. For general section, for defining a new section, we can give area and all its properties. Let us take a simple rectangular section of 0.2 cross 0.2 meter, that is 200 mm cross 200 mm. Click add button. As you click add, the member will show in the data area. We can define the material for the member. Now the member is there. Now we have to assign this member to our elements. Use cursor to assign this property and click assign. Now you can see the cursor will change. The R1 shows the reference number for the section. It is section 1. By double clicking we check the properties of that section also. Then specification, then supports for our structure. From data area, click create support, create button. A new dialog box open from where we can select fixed, pin, joint, fixed butt joint, enforce joint. Right now we are selecting simple fix support. Select the support and use cursor to assign to nodes you want. Then click load definition tab. Click on load cache detail and then click add button. A new dialog box open. We have to generate primary load on our structure, so we select primary load. Uh, then loading type, that is whether it is dead load, live load, roof load or any other. Select the load type. Then title your loading, that is dead load. Then click on end button. You can see on the data area the dead load is created. Now add definitions to dead load. That is, first one is self load. Self weight of the material is acting vertically downward. So we had selected globally y axis and negative shows the downward direction. Click add. Now for uniform load, give a uniform load. Vertically global y axis. Click add button and close the tab. Now we have to assign these properties to our members. Use cursor to assign. Click assign those properties to all members of our structure. A self attacks on all the elements. Similarly, assign UDL to our member. Again, an autosave option appears. Click yes to save your project. As data is modified, pop-ups again. Now we can see its front view by zooming out the structure. Now recall again the whole process. The first step is job information, where we define the information about our project. Then we define the geometry of the structure. give members note their coordinates, etc. Then member property. Then we applied support reaction. The fixed support. Then at last we apply the load definition to our structure. Now in next step is analyzing the structure. So first click on the analysis button, print tab from the page bar, and then add perform analysis. It appears on the data area. Now from menu bar, drop down analysis button and click run analysis. We can ignore warnings, but errors are not ignorable. We have to resolve them by clicking area of error in it output file. Now click on the post processing mode and click done. Here we can see output data response system due to input data or loading system on a structure, that is support reaction, bending moment and shear force. That's for nodes. We can see the reactions at the fixed end nodes pop up in green window. Similarly, we can see bending moment and shear force. The diagram can be scaled using scale toolbox from the menu bar. When we can scale the dimension, bending in y-axis, etc., etc. Then click OK. We can see the edited scaled bending moment shear force diagram. The displacement and deflected animation can be seen in animation tab by accurate scaling the response data. Now we are selecting section displacement. We are scaling displacement diagram and click apply. Then OK. We can see the deflected animation. After post processing, we need a output data file which can be studied and analysis thoroughly, which can be generated from the report tab. Then click on report. By selecting the required output and input data in final report file, we can generate our report file easily. Then click OK after selecting all the needed information. Now we have generated our report file. Double click for zoom in, zoom out. Here we can see our job file number, the reference EA4 builder, and the date of created the project, number of node 6, node, beam, length, section property. By clicking next page, we can see different pages of our report, and we can print or save our project report easily. This is reaction summary. So here we have completed our lecture 2. In next lecture we will see all these in more detail. Okay, thank you.